Hello everyone, welcome to this week's CSE230 Discrete Mathematics. Today we are going to talk about combinatorics, that is counting, permutation and combinations. Let's talk about the product rule first. Say for example you have a problem that says a man has 4 pair of pants, 6 different shirts, 8 pair of socks and 3 pair of shoes. Ignoring the fact that some combinations may look ridiculous, which look anyway, people look ridiculous oftentimes, right? In how many ways can he get dressed? So you have to think of separate ways, right? How many pair of pants does he have? He has 4 pair of pants, right? So he has to pick one pair of pants from those 4 pair of pants. So that is 4C1 or just 4. Now while choosing shirts, he has 6 options. He has to pick one shirt from 6 different shirts, that is 6C1 or just 6. While choosing the pair of socks, then again he has 8 options and he has to pick one, so that is 8C1. While choosing a pair of shoes, he has 3 different pairs of shoes, he has to pick one, so 3C1. So 4C1 into 6C1 into 8C1 into 3C1, that is 4 into 6 into 8 into 3, 576 ways. So the next problem says how many different license plates are available if each plate contains a sequence of 3 letters followed by 3 digits, and no sequence of letters are prohibited even if they are obscene. That means uh, we are free to pick any letters and we are free to pick any digits, given that we're picking them for the right places, right? So the first three places are for the first three places are reserved for the letters and the latter three are reserved for digits. While picking the first letter of the for three places, we're picking one letter out of 26 letters, right? So we pick the, the ways we can pick that letter is 26C1. That is same for the second place as well. We pick one letter from the 26 letters, so the ways we can pick that letter is 26C1, and that is same for the third place as well. We are picking a letter out of 26 letters, so we pick 26C1 into 26C1 into 26C1. In that way we are picking the first three letters for the first three places. Now, coming to the fourth, fifth, and sixth places, right? We are picking one digit out of 10 digits, 1 to 9 and 0, right? So we are picking one digit out of 10 digits. So we can how many ways we can pick that digit? That is 10C1 or just 10. So that is true for fourth, fifth, or sixth places. So every place will be the ways we can pick if for this fourth, fifth, and sixth places are 10C1. So for the first three places we are picking letters, and we have 26 different letters. We are picking one letter, that is the first three for the first three places. The ways we can pick are 26C1, and the letter 3 we are picking digits out of 10 digits. That is why the ways we can pick the digit is 10C1. So in the way we can see the 26C1 into 26C1 into 26C1 into 10 into 10 into 10, that is 10C1 into 10C1 into 10C1. So we are getting this big number. Now the sum rule. So say for example you have a problem that says a student can choose a computer project from one of 3 lists. Say for example these are 3 different lists. These 3 lists contain 23, 15 and 19 possible projects respectively. No project is on more than one list. That means these are distinct projects in three different lists. How many ways the projects to choose from? You see, we are picking one project out of 3 different lists. So we have to pick one project from all 57 list, all 57 possible combinations. The first, if we pick from the first, we are not picking from the second or third. We are picking, if we are picking for the second, we are not picking from the first or third. If we are picking from the third, we are not picking from the first or second, right? So we have to pick one project out of these all possible projects. So how many possible do we have? We have 23 plus 15 plus 19 projects. That is, we have 57 projects. Out of that, we have to pick one project. So how many ways we can pick that? We can pick that from 57C1 or just 57. Why did we apply the sum rule and not the product rule here? Because we are not picking different projects from different tree lists. We are just picking one project from three entire lists, right? That is why we have to use the sum rule here and not product rule. In some problems, we may need to use both sum and product rule to solve. Each user on a computer system has a password, which is 6 to 8 characters long, where each character is an uppercase letter or a digit. Each password must contain at least one digit. How many possible passwords are here? So guys, I need you to pause the video now and think of it and try to solve it on your own. Okay, I hope you have done that, right? So let's see whether you did it correctly, or you may have missed something. So the password can be 6, 7 or 8 characters long. So for 6 we have to find one combination, for 7 we have to pick one combination, and for 8 we have to find one combination. So the possible numbers for password by sum rule is the combination for 6 plus combination of 7 plus the combination of 8. Now we know that we have to pick at least one digit, but it did not say anything about if we pick any numbers, if we pick any password for all that contains all possible digits, right? So but we cannot pick all possible characters that are only letters. For our password we have to have at least one digit, but it did not say anything about letters. So if we pick all numbers, it is okay, but if we pick all letters, it's not. Therefore, for when we are picking a password that is the length is where the length is 6, we have 36 different options. 26 letters uppercase plus 10 digits. We can pick any one, any letter, or we can pick any digits. So we have 6 different places, and we have 36 options for each places, right? So we have 36 into 36 into 36 into 36 into 36 into 36, that is 36 to the power 6. Now we have to exclude the possibility where we pick all possible letters. So we are excluding 26 to the power 6, right? So for 6 places we have 36 options, that is why 36 to the power 6. However, we cannot pick all letters, that is why we are excluding the possibility where we have only letters, that is 26 options for 6 different places, 26 to the power 6. Similarly, while we have 7 different places, we can pick we can pick one character for one place out of 36 possible options, that is 36 to the power 7 for 7 places. We are excluding the possibility where there will be all letters, because it violates the condition where it says we have to pick at least one digit. So we are excluding the possibility where we are picking all possible different letters. That is why we are excluding 26 to the power 7. Same goes for 8. We have 36 to the power 8 minus 26 to the power 8. So here we used the product rule, right? So we can have at least six. We can have a password which is 6 character long or 7 character long or 8 character long. That is why the all possible combination for it would be a possibility of having a 6 character long password plus possibility of having a 7 character long password or possibility of having an 8 character password, 8 character long password. That is P6 plus P7 plus P8. Now, say for example, you have a problem that says, suppose that I love New Jersey t-shirts come in 5 different sizes: small, medium, large, extra large, and double extra large. Suppose that each size comes in 4 colors. The colors are white, red, green, and black, except for extra large and double extra large. Extra large comes in red, green, and black, and the double extra large comes in only green and black. How many different shirts does a souvenir shop have to stock to have at least one of the each available size and color of a shirt? So how many different shirt of small sizes, how many different shirts of medium sizes, how many different sort of large sizes, extra large sizes, and double extra sizes? If we see the tree available on the screen, we can see that there are 4 different shirts of small, medium, and large sizes. That is 4 into 3, that is 12. There is 3 of extra large sizes, that is 3. The 12 plus 3 is 15, and there is 2 more in a double extra size, a double extra large sizes, and that is 15 plus 2, that is 17. So it shows a souvenir shop will have to stock at least 17 different t-shirts to have at least one of the each available sizes and color of the shirt. Now come to a different problem, a different types of problem, that is combination. How many ways are there to select 5 players from 10 members tennis team to make a trip to match at another school? So we are picking 5 players and we have 10 different players to choose from. 5 from 10, and we are picking a team, that is 10C5. And how many ways that can a team of 5 person be formed out of 10, so that 2 particular persons should not be included in any team? So we actually have 10 persons, but we cannot pick 2 of them. That is, we have to exclude those 2 from the options. Now we have 10 minus 2, 8 persons to choose a 5 person team. So we have picking 5 person out of 8 persons, right? That is 8C5. Now the problem says from a group of 7 men and 6 women, 5 persons to be selected to form a committee, so that at least 3 men are in the committee. See, we cannot have less than 3 men in the committee. So to make it a 5 person team, we can have 3 men team, a 3 man committee, 4 man committee, or all of them can be 5 man committee. So when we have 5 man committee, we cannot have any women in the committee. When we have 4 men in the committee, we can have 1 woman in the committee. When we have 3 men in the committee, we can have at best 2 women in the committee. So when you're picking 5 men, so we don't have to pick any women there. So we have to pick 7. We have to pick 5 men out of 7 men. That is 7C5. When we are selecting 4 men and 1 woman, we are picking 4 men from 7 men. That is 7C4. We are picking 1 man from 6 women. Sorry, we are picking 1 woman from 6 women. That is 6C1. So that is 7C4 into 6C1. Now, if we select 3 men, we have to select 2 different women as well. So we are picking 3 men from 7 men, that is 7C3. We are picking 2 women from 6 women, that is 6C2. So the number of ways to do this is 7C3 into 6C2. The total number of this is the addition of all these 3. Right? 7C5 plus 7C4 into 6C1 plus 7C3 into 6C2. Now the problem says the bag contains 2 white balls, 3 black balls and 4 red balls. In how many ways can 3 balls be drawn from the bag if at least 1 black ball is to be included in the draw? So we have 9 different balls and we have to pick at least 1 black ball from there, right? So we can have it in 3 different ways. We can pick 1 black ball and 2 different balls, and 2 black balls and 3 black balls. All of them can be 3 because it does not violate our condition there to pick at least 1 black ball. So when we are picking 3 black balls, we are picking 3 out of 3, that is 3C3. We can pick that only in one way, 3C3. So when picking 2 black balls, we have to pick 2 black balls out of 3, that is 3C2, and we have 6 different balls and we have to pick 2 white balls and 4 red balls, that is 6 non-black balls, right? So we have to pick 1 from there, right? So we are picking 1 from 6 balls, so that is 6C1. Now if we are picking only 1 black ball, so we are picking 1 black ball out of 3, that is 3C1, and we have to pick 2 balls out of the 6 different non-black balls, that is 6C2. The number of users we have to sum it up. Option 1 plus option 2 plus option 3. Option 1 is 3C3, option 2 is 3C2 into 6C1, and option 3 is 3C1 into 6C2. So I started my TV series journey with Prison Break. I loved Michael Scofield. So here is a problem based on him. So he's back to break another prison, and you're helping him. You are a discrete mathematics student, so you know how to calculate and count. So he needs 3 types of persons, that is mechanic, diggers and guards. Alright, and he surveyed and he found that there are 4 mechanics, 3 diggers and 2 guards in the prison who will be able to help. So he needs 6-person team. That means he has to let go of 3 people there. However, he will want to include himself, that is 5% from 9%. He has to choose. Now he needs 1 guard, exactly 1 guard, and at least 2 diggers in his team. And he wanted you to help find out how many ways can he do that. So there are 2 options. He can pick 1 guard and 2 diggers, and he can pick 1 guard and 3 diggers. So here he's picking 1 guard out of 2, that is 2C1. He's picking 2 diggers out of 3, that is 3C2, and he is picking then 2 mechanics out of 4, that is 4C2. If he selects 1 guard and 3 diggers, that is 2C1, 1 guard out of 2, he is picking all 3 of the diggers, that is 3C3, and the one possible position left for his mechanics, that is 1 position. He is picking out of 4 mechanics, that is 4C1. So in the first options, he can pick like 36 different ways, and in the second option he can pick it like 8 different ways. So he has the total number of teams he can be found, the total number of ways that at a team can be found is 44. We're done with product rule, sum rule, combinations. Now let's get into permutations. All right, so we have to pick first prize winner, second prize winner and third prize winner from 100 different people who have entered the contest. Right, when you're picking the first prize winner, we have to pick it from the 100 different people, right? So that is 100. We can pick that one person in 100 ways. When you are done with the first prize winner, while picking the second prize winner, you can only have 99 people to pick the second prize winner from, because one has already won the first prize. So we have 99 different people left. So 99, you're picking one person from 99, that is 99 ways you can do that. And when you are picking the third prize winner, you are already done with first prize winner and second prize winner. So you have left 98 people to pick the third prize winner from. So if you're picking first prize winner, second prize winner and third prize winner from 100 different people, so you can pick that is in 100 into 99 into 98 ways. In how many ways? Now comes the second problem. In how many ways one can arrange the word A, B, C, D, E? There are 5 different letters, and you can have you have to arrange it in 5 different ways. That is 5P5. Now there are 5 yellow, 4 green, and 3 black balls in a bag. All 12 black balls are drawn by one and arranged in a row. So find out the different arrangement possible. Now we have seen in the theory that why we can pick the 12 different balls in 12 factorial ways, as they are in 5 of them are of different same color, 4 of them are of same color, and 3 of them are same colors. We have to divide it by 5 factorial into 4 factorial into 3 factorial. So the answer is 12 factorial divided by 5 factorial into 4 factorial into 3 factorial. Now comes the next problem. It says how many ways a 3-digit number can be formed from the digits 2, 3, 5, 6, 7, which are divisible by 5, and none of the digits are repeated. Now we know a number is divisible by 5 if the last digit or unit digit is 0 or 5. So we have 3 places, and if we pick the last digit to be 0 or 5, we have to pick it from the number sets given in the question 2, 3, 5, 6, 7. So we have to pick the 5 from there. So there is only one way of doing it. We have to pick the 5. And in the second place, if 5 is placed at the unit place, so we have 5 digits remaining. In the tens place, we can pick any of the 5, so we can pick it from the 5 different ways to pick it. Now we have picked in the unit place, we have picked in the tens place. The only remain place is 100 place, right? So we have to pick it from the 4 remaining digits. So here we can pick in 4 different ways. So in total number of ways we can pick the number 3-digit number from the given numbers is 20. Now we have to find how many ways 6 rings of different types can be worn in 3 fingers. All right. So the first ring can be worn in 3 fingers, that is 3 ways. And the second, similarly, each of the 5 remaining rings can be worn in 3 different fingers, that is 3 ways, right? So we all the 6 rings can be worn in 3 different fingers, that is all of the rings have 3 options to be worn, right? So that is 3 into 3 into 3 into 3 into 3, that is 3 to the power 6. Now we'll be talking about circular permutation. This is the very last concept of your this lecture so let's talk about this. In case 1, we're talking about only circular order. So how many ways can 7 boys be seated in a circular order? Remember, we have to look at the axis of symmetry here. So in a circular order, we have the angle is a 360 degree. So we have to divide it by 360 divided by 7. All right. So the arrangement possible is a 7 factorial divided by 7. So we are leave with 6 factorial. In easier way to remember this is, when we are talking about circular table, we just leave we just leave one place to be fixed dated. Otherwise, the circular order will not change. So that is why we are left the arrangement in the number of arrangement possible is 7 minus 1 factorial, that is 6 factorial, that is 720. But it's not the same case when we're talking about the necklace, because the necklace is further symmetric rotation of 180 degree. So when you're talking about necklace, the two sides of necklace are the same thing. All right. So that is why when you're talking about necklace, we have to further divided by 2, because the necklace is a symmetric the rotation of 180 degree around the axis. So after 180 degree, the after 180 degree, the necklace is the same. All right. That is why the two sides of necklace are symmetric, and it's a circular as well. So when we are thinking about necklace, we have to leave one, as we need to take it as a reference, that is, as it is a 7-bit necklace, we can arrange it by 7 minus 1 factorial because of the symmetric way. So that is 6 factorial, and as it is the necklace is also symmetric by 180 degree rotation, so we have to divide it by 36 by 180, that is 2. So 6 factorial divided by 2, so that is 360 ways. In how many ways can 5 girls and 5 boys form a circle such that the boys and girls alternate? So the 5 boys, if we take the boys as a reference, so the 5 boys can be arranged in 5 minus 1 4 ways. Given the girls and boys alternate, hence there are 5 places for the girls, the 5 ways. So if we take the girls as the reference, we could arrange the girls in 4 factorial, and we can then put the boys in alternate ways, that is 5 factorial. So we have to pick boys or girls first, and that way whoever we pick first, we can arrange it in minus 1 ways. So here we are picking the boys first, so 5 minus 1 4 ways, as this is a circular way, and the 5 girls are left with alternate places, so we can arrange the 5 girls by 5 factorial. So the answer is 4 factorial divided by 4 factorial into 5 factorial, that is 24 into 120. Thank you. I hope you understand these problems. Practice more problems from the book, and we'll give you assignments this week. I hope you solve those too. Thank you.